Hello everybody. In today's video I'm gonna show you how to solve exponential equations. But before I'll start, I have to say that we are not going to use logarithm function to solve these equations. I will show this maybe in my next video, or like not next but in a couple of weeks or maybe month. For solving exponential equations we will be using well-known formulas which are listed here on the right side. When I'll be using one of them, I'll tell you how and why we use them. Then very important thing to realize when we solve the exponential equations, we are trying to rearrange the equations or simplify both sides of the equation, the expressions, so that we will come to the equation where we will have the same basis and let's say different exponents, and if the bases are the same, then we can simply write that the equation is true if and only if also exponents are equal. You will understand during my solution of the equations. Next thing I want to say, and in this video I will show you, there are like three methods to solve the exponential equations. The first one is called, like by me, I call it the same basis, because we simplify the equation so that we have the same basis, and then again, as I said, based on this fact, we have the same basis, then the exponents must be equal as well, so that the equation is true. The second method is called factorization. You will see during my today's video. And the last method we are using is the method of substitution, and this is not gonna be shown in this video but in the next video. So let's start with the very simple equation, which can be, or our equation is 7 to the power of 2x plus 1 times 7 to the power of x take away 5 is equal to 7 to the power of 3x plus 2 times 7 to the power of x take away 2. Now we want to rearrange the equation so that it will be in this form. The easiest way how to do, and in this case we will use this formula or fact. When we have the same basis to the power of different exponents, and we multiply them, then we can simplify it like the same one basis and the addition of the exponents. So let's do it here. It would mean that then it's gonna be like 7 to the power of 2x plus 1 plus the second exponent is x minus 5 is equal to 7 to the power of 3x plus 2 plus the second exponent, which is x take away 2. Now we have the same basis, so based on this fact, we know that this is true if and only if the exponents are equal. So we will get a very simple linear equation: 2x plus 1 plus x take away 5 must be equal to 3x plus 2 plus x minus 2. If we simplify both expressions on both sides of our equation, it's gonna be like 3x take away 4 is equal to 4x, this is it, because these will cancel each other. Now, as I want to have like positive coefficient in front of my x, I will do like take away 3x from both sides, so negative 4 is equal to x. I also prefer to have x on the left side, so x is equal to negative 4. To be sure that our calculation and we did everything properly, we have to do the check of the equation. So let's see what is the value of the left side for x being negative 4. It is then 7 to the power of 2 times negative 4 plus 1 times 7 to the negative 4 minus 5, which is 7 to the power of negative 7 times 7 to the power of negative 9, which is 7 to the power of negative 16. This is the value of my left side. It's not necessary and needed, as you will see later on, to evaluate really what the number is behind this. So let's see what is the value of the right side of our equation for x being negative 4. It's gonna be 7 to the 3 times to the power of 3 times negative 4 plus 2 times 7 to the power of negative 4 minus 2, which is 7 to negative 12 plus 2 is negative 10 times 7 to the power of negative 6. Again, we are using the formula here on the right side, which is of course 7 to the power of negative 16. As you can see, the value of my left side for x being negative 4 is equal to the value of right side for negative 4, which means we can make the conclusion the left side is equal to the right side, so the set of our roots is one element set, and it consists of number negative 4. So this is the solution of the first equation. As you can see, we simplified or reordered the equation so that we had the same basis here, and then we just write the equation for the exponents, and we did the calculation, and this is it. Let me show you another example, which is not like, let's say, that easy, but it's a little bit different than this one. And my equation, my second equation, will be like this: 2 to the power of 3x times 4 to the power 3x minus 3 is equal 8 to the power of 2x plus 1. As you can see, and maybe you start like being scared that we don't have the same basis here, but I'm pretty sure you can see that this will become like the same basis, because number 4 can be written as 2 to the power of 2, and the number 8 can be written as 2 to the power of 3. Okay, so let's use this fact, and our equation will become like 2 to the power of 3x times 2 to the power of 2 to the power of 3x minus 3 is equal 2 to the power of 3 to the power of 2x plus 1. Now we will apply this formula or this fact, which means our equation will become like this: 2 to the power of 3x times 2 to the power, and we multiply the first term of our outer exponent and the second term of our outer exponent by number 2, so that we apply our formula. So this is going to be 2 to the power of 6x minus 6, which is equal to 2 to the power of 6x plus 3. Okay, now as you can see, this is the same thing as we had in the previous equation. So this is going to be 2 to the power of 3x plus 6x minus 6 is equal to the power of 6x plus 3. Now we have the same basis. I'm not gonna simplify this expression because I will do it now. If the bases are equal, then the exponents must be equal, which will lead us to the simple linear equation: 3x plus 6x is 9x, take away 6 is equal to 6x plus 3. And we do simplify or rearrange our equation, take away 6x plus 6, okay, which is gonna be 3x equals 9, and this would mean we multiply both sides by 1 over 3, so x is equal to 3. Again, you are now supposed to do the check if the solution is correct, so let's do it. Left side for number 3 is gonna be 2 to the power 3 times 3 is 9 times 4 to the power 3 times 3 is 9, take away 3 is 6, and we again applied the same rule as before, so it's gonna be 2 to the power of 9 times 2 to the power of 12, which is equal to 2 to the power of 21. I'm not gonna evaluate this number again because it's gonna be like really big number, and you will see that it's quite enough to have this number as the value of the left side for x being 3. Let's see what is the value of the right side for x being 3. So it's 8 to the power of 6 plus 1, which is 8 to the power of 7, which is then gonna be 2 to the power of 3 to the power of 7, which is of course 2 to the power of 21. So as you can see, our left side is the same as the right side, so you can make the conclusion, and the set of our roots or solutions, in this case solution because it's only one, is one element set, and it is number 3. Okay, so these are the easiest exponential equations you'll be solving, and this is the procedure or algorithm you apply if you see something like this. So let's now have a look how to solve another kind of exponential equation by using the factorization method, and I'll explain how to identify when to use this method. The thing is easy. Let's have a look on this equation. 4 to the power of x plus 2 minus 4 to the power of x plus 1 is equal to 3. Now, as you can see, the difference between the previous equation and this one is that we have here some kind of base 4, but here is number 3, which has nothing to do at the first look with number 4, but this is how it goes with mathematics and as well in life, I guess. You just try to use the procedure or the method you know, and you will see what will happen during your solution. So let's have a look. 4 to the power of x times 4 to the power of 2, take away 4 to the power of x times 4 is equal to 3. And here comes the factorization, which means you look for the common factor of these two terms, which is 4 to the power of x, and you simplify the expression this way. 4 to the power of x times, I will use the fact that 4 to the power of 2 is 16, take away 4 is equal to 3, and as you can see, the equation will be 4 to the power of x times 12 is equal to 3. Maybe some of you already can see what is gonna happen, because we want to rearrange our equation so that we have the same basis on both sides of the equation. So the only thing we can do is to multiply by 1 over 12. So 4 to the power of x is equal to 3 over 12, and this can be really like simplified to the fraction 1 over 4. As you can now see, we have number 4 here and number 4 here, which is quite close to what we want to get. So now the question is, how can from this fraction become 4 to the power of some number? And yes, you are right. In this case, we will use our third equation or third formula, which says if you see something 1 over a, then you can rearrange or rewrite this like a to the power of negative 1. So using this fact, we can come to the equation 4 to the power of x is equal to 4 to the power of negative 1, and then you can see that x must be really equal to negative 1. Again, you do the check by your own, and you will see that our calculation is correct. So you can, after doing the check, make the conclusion that the set of the roots or solutions is again one element set, and it is number -1. Okay, so this one was easy. Now let's have a look on more complex example. And we'll be solving this equation by using the factorization method again. So let's have the equation, which is 5 to the power of x plus 2, take away 4 to the power of x plus 2 is equal to 5 to the power of x plus 1. Okay, if you see something like this, you maybe realize that we have really, again, not the same basis, but again, as I said in the previous example, you start to rearrange or play around with the expressions, and you will see if you can come to something you already know how to solve. So let's start. This can be like 5 to the power of x times 5 to the second power, take away 4 to the power of x times 4 to the power of 2 to the second power, 5 to the x times 5. Now, what is important if you see something like this, and it's quite common procedure how to solve such an equation, is that you put the expressions which have the same basis on one side, and the expressions which have the different or the second basis on the other side. So basically, in this case, you take away 5 over x times 5, 5 to the power of x times 5, and you simply add up 4 to the power of x times 4 squared. So the equation will become now 5 to the power of x times 5 squared, take away 5 to the power of x times 5 is equal to 4 to the power of x times 4 squared. Now, if you see some expression like this, what is the easiest way? Yes, you look for the common factor, which is 5 to the power of x, and you do the factorization, so it's gonna be like 5 to the power of x times, and I will use the fact that 5 to the 5 squared is equal to 25, take away 5 is equal 4 to the power of x times, and I will again use, instead of this exponential expression, the number, because it's nice number and quite easy number, which is 16. Now 5 to the power of x times 20 is equal 4 to the power of x times 16. Probably, and I'm pretty sure, you can see that these two numbers have something in common with these two bases, but maybe not. So let me show you and explain what to do. I want to have x's, and this is like the general procedure to have x's on one side of the equation and the numbers on the other side. So let's multiply both sides of our equation by 1 over 4 to the power of x times 1 over 20, okay? So that I will get rid of 20 here on the left side and 4 to the power of x on the right side. So my equation will now become to 5 over 4 to the power of x is equal to 16 over 20. As you can see, this fraction can be like simplified, numerator and denominator divided by 4, and it will become to the fraction 4 over 5. Now I'm pretty sure you can see that this is number which can be very easily written as 5 over 4, so that we have the same basis, and the question is, which fact do we use, or which formula? Yes, again we use the third formula, but now we do it like other way around. So we come from the fraction to the fraction, and we change the basis. we change the numerator with the denominator, and then the exponent will be -1. So my equation is gonna be 5 over 4 to the power of x is equal to 5 over 4 to the power of -1, and you can see very easily now that x must be equal to -1. You again are supposed to do the check. If you do so, you will find out that our solution is really true, and the conclusion is the set of the solutions. In this case, only one solution, so one element set, and it is number 1. Okay. So these were like 4 easy equations, exponential. We use the same basis method or factorization method, and this is all for today's video. I'm gonna show you one more example in the next video, or as I have some time, yeah, okay, let's do it here, because the next equation can be solved by factorization and then the same basis method, but in this case it's gonna be like really little bit complex thing. So let's start. Our equation is 5 to the power of x plus 6 minus 3 to the power of x plus 7 is equal to 43 times 5 to the power of x plus 4 minus 19 times 3 to the power of x plus 5. Okay, and as this is really quite complex equation, and I want to have quite a lot of time or more time for solving this, I'm really gonna show you how to solve this equation in my next video. So thanks for watching, and see you during our next video session. Thanks, bye.